Hello everyone, today we're going to start looking at dial calipers and how engineers start actually measuring the objects that we work with every day. Dial caliper is a precision instrument that engineers and manufacturers use to measure the objects that they're working with. Primarily we use it for smaller tools and smaller pieces. The limit to a dial caliper is about 6 inches. Now there are 4 pieces that we will measure, that is the outside diameter or the thickness of an object, the inside diameter or the space width, step distance, or hole depth. Now again, the longest you're going to see a dial caliper measure is about 6 inches, maybe a little bit longer. So we are working with small parts here, but with small parts, that precision is incredibly important. So as we're looking at what pieces we actually measure, we are going to look at the large jaws on the front first. Now a dial caliper is going to measure an outside thickness or a width with these. As given in the example here, we see that we're going to measure that outside with the large jaws. Now the back 2 prongs we're going to use to measure inside distances or internal faces. So as the example given, we see a hole where we're measuring the diameter. That's how we're going to use these 2 back prongs to measure that. Now that's not the only things they measure. We can also use them to measure step. Now the step is what we're going to use to measure where a surface drops down to a second surface. Here you see that we have the top and a cutout, and we need to find out exactly how far that cutout is, and we can use the dial caliper to measure that. The final piece is the prong on the bottom of the dial caliper. Now this will allow us to find a depth, such as a hole depth or recess depth, and that way we can actually get into that section and find out what that depth will be. Now there are a few things about a dial caliper we do need to know, which is some simple terminology. One is the blade. That is what we call the immobile piece of the dial caliper. The blade is where we'll also see all of our measuring values placed, and it's the piece that does not move. The piece that does move is called the slider. This is our mobile part that will move up and down the lower jaw to help us understand our measurements. Now let's take a closer look at the blade. On the blade, we see our measurements in inches and tenths of inches. That's right, we are measuring in a decimal system with the dial caliper, unlike a ruler, which uses fractions. So the dial caliper is going to give us a decimal measurement, and each one of these smaller numbers represents a tenth of an inch. Now we'll determine smaller measurements on the dial using the pointer. So the dial will measure down to the thousandth of an inch with the pointer pointing at the number we're going to use. So here we see that we are just past the 7. Now that 7 is our reference edge, and that tells us exactly what that first number will be. So we haven't quite got to 1, but we have got to 0.7. Now the rack is that gear train we're going to see that let us roll forward and backward on the object. That way on the slide moving up and down the blade will be used by using a wheel. We'll roll backwards and forwards, help keep everything accurate. Now as we start using a dial caliper, we need to understand some steps to make sure everything's accurate so we can make our measurements. First, we need to calibrate the dial caliper, and we do that by a method called zeroing. You see the dial lock, that's used to release the dial so that we can move it around. And it's simple enough to zero a set of dial calipers. All we have to do is rotate that face so that the needle and the zero line up, and then we tighten the dial lock again. Each time the pointer completes a rotation within the dial, the reference edge on the slider moves the distance of 1 blade increment. That means every time the dial goes all the way around once, we've moved a tenth of an inch. So each tenth will cause a full rotation on the dial. Now the dial itself is going to tell us a thousandth of an inch. Notice it is broken up 100 times. So we'll know our thousandth of an inch from the dial. So let's do a practice. We see that we have what looks like a rubber gasket, and we're going to use our dial caliper to measure that. Now I see that I've gotten past the 1 inch mark. Well, that's my largest hole number, so I'm going to write that over to the side as 1 inch. Well, my 10th inch, I see get past the 4. Now that leading edge has not got past the 5 yet, so I'm only going to say I have 0.4. So I've gotten past the inch mark and past the 0.4 inch mark. The next place I need to look is at the dial. I see that I'm past 3, and I'm getting to that point, looks like 37, so I have 0.037 inches. So that gives me 1.437, but whenever we do a measurement on a dial caliper, we always estimate to the one place that I can't quite see. So we go one more size down. And since we're at the thousandth of an inch, that will take us to the 10,000th of an inch. So if I zoom in really close to my dial caliper, I'll see that it's just past that 0.037. So I'm going to say 0.0001 inches. So I'll put these all over to the side. I know I got past 1 inch, 0.4, 0.037, and 0.001, and I add those all together to find my measurement would be 1.4371 inches. And that's the approximate size of my gasket. Now I can say with a great deal of certainty that 1.437, that 0.0001 inches is our estimated digit. That is our last digit, and that gives us a very accurate measurement of this gasket. So let's measure a block and do this again. See, I can't say I'm past the 1 inch, and I'm past 0.4 inches. If I look in at the dial very closely, I see that I get at least a 0.002, and maybe just a little bit past. So we'll say 0.0002 inches. That gives me a measurement of 1.4022 inches. Remember, as you're measuring with dial calipers, we can get to the 10,000th of an inch, and our final digit is always the estimated digit.